Let's get started. I already imported those two images, the plan drawing and the elevation drawing, and those drawings I found in the article on Amazing Architecture. As I said, I put the link to the article in the description below. Here at the last pages you can find those drawings, and it's enough with the plan drawing and one elevation drawing. First we are going to draw this rectangle. The rectangle is 6 by 6 meters. We go to curves, primitive, rectangle, and Grasshopper wants a plane, x and y, size and radius. Radius is 0 and x and y is 6 meters. Since we are not going to change the size, we will use a panel. So I write here 6 meters and connect it to x and y. You can use a slider, but I use sliders when I want to change the values. And since we are not going to change the values in this case, I'm using the panel for the input values. But yeah, you could use the slider as well. But I'm using sliders only when I want to experiment with values. Now we are going to rotate this rectangle 45 degrees. We are going to transform and rotate. Grasshopper wants geometry, that's our rectangle, and you see Grasshopper rotated it with 180 degrees or 0.5 p. In order to work with degrees, we have to right click it, change to the degrees, otherwise Grasshopper is working with radians values, and we want to rotate it with 45 degrees. I will grab the panel again and write 45 degrees, since I'm not going to change the value, rotation value. Now we can hide this original rectangle. Now I'm going to draw a line here between this and this point, and first I have to find those points. We are going to set and choose list item and connect the geometry. Now it's the first time I'm using this component. I just want to be able to extract the points, and it looks like this component is making it possible. Going to panels. Now I have only one polyline. Now here I have 4 points. 0, 1, 2, 3 and 4. So 0, 1, 2, 3 and 4. Actually, I have 5 points here. And if I connect those points in the list item, the start is 0. The 0 point is this one. And I need 0, 1, 2. I think I need the second point. I will copy this and I will take the panel tool again and connect to this list item. Now I have the second point. I have 0 point and the second point, and I will connect those points with a line. Go to the curve again, primitive, point A and point B, and now we have a line. The next thing I'm going to do, I will offset this line by 2188 divided by 2. We are going to utilities, I think, offset curve, and we need distance. We are going to use mathematical operations here. 2888, paneling tools again, since we are not going to change the value, divided by 2. That's the distance. Now I have that line. The next thing I'm going to is I will divide this curve in order to get points. Divide here. Divide curve is under division. I will just connect the offsetted curve to this divide component and now I have 11 points. That's enough. So now I'm going to use those points to generate parabolas, and I'm going to generate 6 parabolas. One, this one, this one, this one, that's 3, this one 4, this one 5, and the lowest one, that's the 6th. We are not going to draw the banks. I show you on this article. We are only going to generate the shell, the protective shell. We are not going to work with these sitting banks. If you want, you can do it on your own. I just want to show you the principle, how to generate this pavilion in Grasshopper. I think this is the architect. Now I have 11 points, and I'm going to move those points so that they follow those curves. And I'm going to use graph mapper with parabola function. So I bring the graph mapper on the canvas, and it's empty. So you right click and choose a function. And in this case, in our case, it's parabola function. And for that, we start to bring the range on the canvas and move component. Then I will explain to you how you will connect those components with each other and the logics behind. Range, I think we have it here under the set. If we go to primitives and bring the panel on the canvas, we can see that by default the range has 11 values, and we have 11 points here, so that's okay. We don't need to change anything here. Now I will bring the move component, since we are going to move the points, and the move is under transform. Grasshopper wants geometry, and the geometry is the points we want to move. So I will connect the points to the geometry, and here we need a vector to move the points. And I'm going to move the points in this direction, that's X direction, and we go to vector menu and choose unit X. And then we are going to move the points according to this parabola function. And now you see we have new points, but we don't see any change here because the parabola function move points between values 0 and 1, and we have other values. Our rectangle is 6 by 6 meters. We have to multiply those values, and since we are going to experiment a little bit with the values, we are going to use the slider, and we are going to choose multiplication from the math menu. And we are going to multiply those values here with the slider values, but the slider values are very low so far, so I think we start with 1000. Between 1000, we will have the range between 1000 and 3000. And now you see what's going on the screen. I always forget to check this green button. So now you see the changes on the canvas. I will hide these points, and it's changing in the opposite direction. I want to work with this side of the rectangle. So what we are going to do, we will introduce negative here, so it's going to use negative values instead. Now we are working with the right direction. The curve we want to work with, I think that's might be this one. Now we have to work with the graph mapper a little bit. Actually, we don't need a negative value here. We can change the parabola instead. Now it's changing. And then we can change the values here. We can grab this point and change values. And now it looks pretty good. Before we start working with the parabola function, I want to cut the curve here and here. That's why we are going back to this offset curve and We can go to intersection and see what we have here. Curve, curve. We could draw a curve here and then mirror it and cut this green curve with those two new curves. Let's try that. Let's draw curves first. Have 0 point here. Actually, we are going to do like this. We are going to cut this curve with the rectangle. Let's see what we are going to get. We go to intersection, curve, curve, and we have the line, that's this offsetted line, A, and then we have rotated rectangle, B. Now we have those 2 points. I think I need list item again. I have point 1, and now I will extract the point 2, choosing in this number 1. Now I'm going to draw a line between those 2 points. This one and this one. Now I have a new line. Basically, it's a little bit too much, but I think I will go with that. We are going to divide this line instead of this offsetted line because this offsetted line is too long. We are going just to connect this curve to divide. Can erase this. And now we can work with the parabola. Could be here. I think that's fine. We can see the values that this parabola function produced. We can go to the index 5. I think that's the middle point. And it's pretty okay. It's not perfect. You see this point 4 or the index 4 should be the same as the index 6. It differs a little bit. And if I get a client who wanted me to do this, I will construct the parabola mathematically, but for the purpose of this exercise, the parabola function and the graph mapper will do. But it's not perfect. And you can also see the 0 index should correspond to the index number 10, but it differs a little bit. And index number 1 differs a little bit from the index number 9 and so on. But it doesn't matter. As I said, for the purpose of the exercise, it will do. Another tip I can give you is make sure that this point is on the middle. If we change this point, then you see the parabola is not symmetrical, if you can say so. So we bring it to the middle. That's what I want to say about the parabola function, and that's the bottom parabola. Now I have to find this parabola. I can move this bottom parabola by, let's see, I already have a line, so I can measure right distance here between this point and approximately here, and the distance is 2921 millimeters. I'm going to move this parabola by 2900. I think it will do. Actually, I'm going to use those points always as an input value for all the parabolas. That's those points. What I'm going to do, I'm going to store them first in this point house, so to speak, and I'm going to have hidden wire display as hidden. And now I'm going to move those points by 2920 in the Z direction. We need vector and a new move component, geometry, new slider, 2800, between 2800 and 3003. I need to change the values for some reason, so in that case it's good to have slider as the input value instead of the panel. And here are my points. I don't need this line anymore, I will erase it. And now I will bring the parabola, graph mapper parabola function, parabola, and range, and the range component, and move again to move those points. Move is under transform, move geometry in X direction to start with, vectors, X vector, we will multiply first. I think I could use this slider. I can copy this slider. So let's see the points and change the parabola. We could have negative as well, but it's easy just to change the direction of the parabola. It's a little bit messy on the screen, so I will turn off the first parabola. We'll turn off this line as well. I can turn off those points and even those stored points. Now I know what I'm working with. I just want to see those points on the screen now. And I'm going to distribute those points along this curve and along this curve. You see here. If you follow my mouse on the screen, that's this curve. So that's the peak, and then I think this will do. I'm not sure. Yeah, this will do. In this view, now we have to fix those points in the front view, and we will use the parabola function, but instead of X vector, we are going to use a Z vector. I will copy the whole definition. And as I said, instead of X, we are going to use Z vector. Let's see. Something is not correct. I think we'll change this value. We're going to change the parabola as well. Now I understand. We're going to move those points, not those. So we're going to connect and turn off those. So now it's correct. Change here maybe to 500. Oh, it's pretty okay now. So now I have two. This is the upper parabola and this is the lower parabola. Preview. Now I'm going to generate the curves here from those points. Go to curves and I'm not sure, interpolate. I think we interpolate will do. Now I have the lower curve, this one, and copy this and generate the upper curve. And now what I'm going to do is good to group those components so that you know what you are working with. Control G. And this one is the lower curve. Choose, I work a lot with scribble component or with scribble properties. I will write here curve 1, for instance. Make a new group, and this one I'm going to call curve 2, and make a new group. Now I have curve 1 and curve 2. And I need them in order to generate the sticks for the first row. Now I'm going to work with the curves for the second row. I will turn off those first curves temporarily for the moment, because I don't want to have so much on the screen. It can be confusing. it is confusing to have so much on the screen, so anything you don't need, just hide it or disable it. You do as you want. Maybe I can group this one as well, and no, but that's not necessary. I have curve 1 and curve 2. We can organize it a little bit anyway. It's good to organize the script from time to time, otherwise it's going to be a lot of spaghetti all over the screen. See, I have one slider too many. And we are going to do the same thing for the row 1 and the row 2. We will just work with graph mapper and parabola function and move the points following those drawings. That's the points we are working with. So I'm going to take a new store component and use hidden via display. Move down here and work with the second row, and the second row starts here. Let me draw a line, and the second curve is here. Let me draw a line. That's good to know when we are moving the points. Now I'm going to measure the distance between these points and this line, approximate distance, and it is around 4044 millimeters. I'm going to move these points in Z direction. We need vector, unit set, move component, and the slider. I will have range between 3900 and 4500. Now we just connect the components. I think they are a little bit too high. They are here instead of here, so I will measure again. Something was wrong. The distance is 2329. I will change the slider. I will change the range in the slider between, let's say, 2200 and 2500. And now the points are here. I will write 2330 and press this green button. And now we see the points are at this height. That's acceptable. Now I have to find the curve in the plan view, this curve in the plan view, and I think this is the third row, this is the second row. This curve might be this curve. If you follow the mouse arrow on the screen, I think that's this one. I take the graph mapper again and choose parabola function, graph types, parabola, range, we do the same things here, and now we will move those points or distribute the points according to this parabola function. We will move them in the x direction, that's why we need vector x, unit x, and move component as well. So we connect geometry to geometry, direction, x direction, and we also need to multiply because the values are between 0 and 1 and our rectangle is 6000 by 6000, so values between 0 and 1 will not be visible on the screen. Multiply component, connect these values from the parabola function and multiply them with, we will have the slider. I can copy this slider. And let's see. We will turn off those moved points first, and then we will also turn off the original points. Now it's quite clean on the screen here, and we will change the direction of the parabola. Now we can work with the parabola. The peak is here, and this and this point. Let's see, I have to zoom in. This point should be in the middle. So this point is here, this point, it looks pretty good actually. So this is the parabola we worked with in the top view. No, actually it doesn't look good. This is okay, this is okay. We want this is something else, and this point shouldn't be here. I think I have to turn off these 2 points as well, and I will turn off these curves. Preview off, preview off. They're still here, preview off. Now they are gone. Turn off this offsetted line and even this line, the original line. So it's pretty clean on the screen now. So now we can work with this parabola. Let's see. It's pretty good now, and I will leave it there. Now I'm going to distribute those points along this curve, and for that I need vector. In this case we are going to have a set vector, a multiply and a slider. So I'm going to copy this definition and instead of x we will have set vector, unit set. And we are not going to move those original points, we are going to move these points. I will turn off these points, and now we will distribute these points along this curve. I will change here the range. I will have the range between 300 and I think 1000 will be enough. No. We need negative here. It's not enough just to change the direction of the curve. Now it works, because this is 0.0, and when we multiply this value here with this value, it's always going to be 0 and it will stay in this position. I hope that you can understand this explanation, because the values of the parabola are between 0 and 1, and this value is 0. When we multiply it with this, it's not going to change, so this point will not move. You see, it's staying here. And negative I need because I want these points in the opposite direction. One thing I will do here is to make sure that this point is in the middle. Now I have the points that will help me to construct a parabola curve. We are going to curves and choose interpolate. I think that's what we did before, and connect all those points to V. And it's not perfect actually, so you can play as much as you want with this. I try to bring those points a little bit down. Let's see here. Yes, this is much better. I will do a video about how you can construct a parabola mathematically, but for the purpose of this exercise, the graph mapper will do. As I said before, if a client wanted me to do this, I wouldn't use a graph mapper. I would definitely construct a parabola mathematically with the mathematical operations. Now we have the lower curve. The next we will construct this upper curve. First I have to find it on the plan drawing, and I think that's this curve, this one. I will group this lower curve, Ctrl G, and I see here I will extract the curve from the group so that we are consequent. Remove from the group, so I will call this curve curve 3. As I said, I use Scribble a lot in order to organize components and definitions on the screen. Ctrl G to make a new group, and I will turn on these points. We need just the curves. I will copy these original points. I will turn on the original points. They are here now, and I will move them up here. I need a distance from this curve to the bottom approximately, and as you see it's 4621, and I will copy this. Preview on, and I will change the range of the slider between 4000, press the green button, and let's say 4500, press the green button again. See, now we have the points here on this height, and I will write 4620. 120 here, press the green button again, and now we have the points on the right height. Now we will move those points along this curve. I will copy this, and I will just connect this geometry to this move component. Preview, let's see, turn these points off, and I will turn the original points off. And now we have only these points that we want to work with. And let's see, I think I changed the value of the slider here between 500 and let's say 1000. Press the green button. That's okay, and we will work a little bit with the parabola. I think this will do. And now we will move those points along this curve here. And I will copy this definition. Turn off this component and turn on this one. And now we have these points here. It looks pretty good. We will work a little bit with the parabola. Yeah, I think this will do. And I will copy this curve and connect these points to vertices, geometry to vertices, and now I have the curve 4. And we will organize it a little bit with scribble. We'll write curve 4 and make a new group, Ctrl G. We will also group this, Ctrl G. I will turn off all the curves. Now we have 4 curves. I'm not going to do the last row, you can do that on your own. The principle is the same. I don't like long videos. I think this video is already too long. In the next tutorial, part 3, I'm going to show you how to generate the sticks. That's all for now. Thank you for watching. See you in the next part.